Hello everyone, very good morning to all of you and welcome to our third class of Geography Foundation class. So, this foundation class we have started for UPSC and OPSC. In this foundation class, we will not only cover your prelims, mains, we will cover your CSAT, we will cover your NCERT. This also include the test series and free mentorship. All these things you will get under the single program, and all your faculty, you can see they are expert faculty having experience in multiple reputed institutions. So, we are bringing to your doorstep, you can see all our faculties, and the price is also very nominal, so that student can pay without much effort. So, you can see online price is 20,000, offline price is 25,000. So, both offline, online and hybrid mode is available, so you can join. So, let us start our class from third class onwards. So, yes, so far we have discussed about the composition of earth. So, we have seen that earth is consisting of three types of layers. So, outer layer is called core, then mantle, outer layer is called crust, then mantle and then core. I think you have seen. So, I am just giving a revision of whatever we have discussed so far. So, you can see, so earth is consisting of three concentric layer, just like the onion. If you peel the onion layer by layer, so outer layer is called crust and the middle layer is called mantle, and the middle layer is further divided into upper mantle and lower mantle, and then the inner layer is called core, and core is further divided into outer core and inner core. And we know that the crust, let us see little bit of detail about that. So, you can see the crust is further divided into continental crust and oceanic crust. Okay, so continental crust is thicker and lighter weight, but the oceanic crust is thinner but heavy weight. Okay. Just a second. Okay, so next is about we know the density of continental crust is 2.7, so that is lighter, and density of the oceanic crust is heavier, so that is little bit of heavier. Okay. So, next is about the composition. So, composition of continental crust is Cl, that is silicon and aluminum. The composition of the oceanic crust is Sima, silicon and magnesium. So, this is what we have discussed so far, and then we have seen the mantle, about the mantle, and there are multiple discontinuity. The discontinuity between the crust and mantle, it is called Mohorovicic discontinuity, and discontinuity between crust and core is called Gutenberg discontinuity. That is what we have discussed so far. And second, the mantle is further divided, we have seen that mantle is further divided into upper mantle and lower mantle, and further the upper part of the upper mantle is called lithosphere and bottom portion is called asthenosphere. Let us say this is what the mantle, this is what the mantle, yes, this is what the mantle, you see. So, the upper portion, so the upper portion of this mantle, you can see this portion is called asthenosphere. The upper portion is called, this is called asthenosphere, and above that it is called lithosphere. This portion is called lithosphere, and lithosphere means rock sphere, and this lithosphere is not a single blocks, rather this is divided into multiple plates, and these plates are called lithospheric plates. I think you can see this much portion, the crust plus this much portion is called lithospheric plates, and these plates are floating above a soft layer called asthenosphere. So, because of that, this is asthenosphere soft layer, on the top of that the lithosphere plates are moving from one region to another region. So, that is what the reason for movement of the plates, and whenever plates are moving, they are interacting with one another, and because of that interaction of plates, that is what led to the formation of mountain, that is what led to the volcanism, that is what led to the formation of the mountain, that is what led to the formation of all this volcanic activity, that is what also the reason behind happening of some of the tsunami also, ठीक है. So that is what we are going to discuss. आगे बढ़ते हैं. This is what we have already discussed in our previous class. So just for your I'm just doing a revision. You can see these lithospheric plates. This is not a single chunks. It is multiple, divided into multiple plates, and these plates you can see. It is called the red, I am highlighting in the red color. These are called major plates: North American plates, South American plates, African plates, Eurasian plates, and then Pacific plates, and then Antarctica plates. These are called major plates. These are called major plates because of their vast size. They are called as major plates. Dear student, all my boys, audio, video, everything is okay or not? So please let me know. Dear student, please let me know my audio, video, everything is okay or not, because I cannot see. So आगे बढ़ते हैं. Next one is about the minor plates. So what are the minor plates? Minor plates I am highlighting in the green color. You can see Juanda Fuca. You have to also clearly know that location of this plate. Sometimes they can ask match the following type: Juanda Fuca between the North America and Pacific plates. They can ask about, consider the following plates and their location. So they can ask about Juanda Fuca plates because people generally ignore that, and from there they can ask question. So next is Caribbean plates, Cocoa plates, Nazca plates. So this Cocoa, Nazca, Juanda Fuca, they are very important because that is the reason here there is a Andes. This is the Rockies mountain in the North America because of the Juanda Fuca and Cocoa plates, and the Andes mountain in the South America because of Nazca plate. Okay, then Croatia plates, then Somali plates, Arabian plates, Indian plates. देखो, because of this Indo-Australian plates, these plates actually move northward. And this is colliding with Eurasian plate, and that is the reason you find Himalaya here. So whenever two plates here, let's say this is the Eurasian plates and this is Indian plates, and the Indo-Australian plates, they collide together, and because of that there is a folding and rising of Himalaya happen. So this is what giving you the understanding of how mountain is formed. Okay, ठीक है. So ये सब plates हमें next is Philippine plates. So this knowing of this plates is very important because as you proceed, I will reveal step by step. You will understand. You will get a lot of insights of how this mountain is formed, how this region is prone to the volcanism and all. So you will get lot of clarity as we proceed. Chalo. So next we have seen asthenosphere. Astheno means soft layer. So this is part of the lower mantle, and we have seen the core. Core is consisting of two types. One is called outer core and inner core. Outer core is in liquid state. But inner core is in solid state. Why outer core is in liquid state? Because there it is the temperature dominant the pressure. So whenever more temperature, pressure is less, so it is liquid state. But inner core is in solid state because here the pressure dominate the temperature. I have already explained that in previous class, already available in the YouTube. You can watch that. So there are some seismic discontinuity that is found between the different boundary, like from crust to mantle, from mantle to core. Okay, so what are this discontinuity? So let's see. First discontinuity is called Mohorovičić discontinuity, is found between the crust and mantle. So there can be good question. This can be a very good question. So I am only discussing the important one, but it is given all these details, so you can read that. So next one is Lehman discontinuity. This is lies between inner core and outer core. Baki there are a lot of discontinuities, so no need to know about that. Lehman, and first one is the Mohorovičić discontinuity, that is what you have to know, and Gutenberg discontinuity you should know. Rest they are given, you can refer. Okay, I think you can see here these are the important discontinuity. So first one is about Mohorovičić discontinuity between crust and mantle. Then Repti, so this is between upper and lower mantle. Then Gutenberg discontinuity between mantle and outer core. Lehman discontinuity between outer and inner core. So this is more than enough to know about the discontinuity. There can be question, match the following type of question. So already we have seen the pressure, temperature and density difference, and we know that as we move inside the earth, temperature will increase, pressure will increase, and density is also going to be increased. Okay, chalo. So next is earth major landforms. Okay, so we know that earth, whatever we are seeing on the surface of the earth, be that mountain, plain, lakes, volcanic islands, plateau, whatever may be, it is the internal, it is the you can say eternal means complete, or you can say continuous fight between two important forces. One is called endogenic, that is operating within earth, another is called exogenic. The fighting between endogenic and exogenic is actually helping to have all this mountain, plateaus, plains, everything on the surface of the earth. So we are going to see one by one. So first one is about the mountains. Okay? So you can see whatever we are seeing on the surface of the earth, it is because of fight between endogenic, that is force that is within earth, and exogenic force that is external to the earth. Okay? So these process ranging from violent mountain formation, sometimes this is also responsible for earthquake, volcanism, and lot of other activities. Okay? So here we are going to see about the different type of mountains that we have found on the surface of earth. Already we have discussed that fold mountain, plateau mountain, volcanic mountain, dome mountain, and fault block mountain. So already we have discussed about the fold mountain. Fold mountain are found generally when two plates are converging. These lithospheric plates, I think already I have discussed you. The earth lithosphere is divided into multiple plates, and when these plates are interacting with one another and they coming together, converge, and then they rise to form fold mountain. Classic example of fold mountain is our Himalayas. Okay? So characteristics of the fold mountain, I think you know, they are lofty peaks. I think if you see about the Himalaya mountain, they are approximately around 6 to 8 kilometer height. Then deep valley found there, rugged and steep terrain, high seismicity, tectonic activity, parallel ranges, and complex topography are also found there. Okay? So types of fold mountain. So this is not much important. You can see this is one lithospheric plates and another lithospheric plates. When they comes together and at the meeting place, there is a rise and formation of this big mountain. So this is what called fold mountain. Okay, Alex, all good? It's audible, any issue? Happy birthday, Santoshini. Happy birthday, Santoshini. Really, you know, may God bless you, and this day may be very special, and God give you, God give you all the blessing so that you will achieve pinnacle of your success. Happy birthday once again, Santoshini Shahu. God bless you dear. अच्छे से पढ़ाई करो. Please study very hard and ensure that you will get success. Okay. चलो बहुत बढ़िया है, बड़े खुशी लगा कि आप लोग शेयर कर रहे हो अपना पर्सनल चीज़ें. आई एम रियली हैप्पी. ठीक है. सो मैपिंग सम ऑफ द माउंटेन दैट आई हैव गिवन फॉर योर मैपिंग. इट इज स्टार्टिंग फ्रॉम fold mountain like Himalaya. You have to map Alp mountain, Andes mountain, Rockies mountain, Ural mountain, and Aravalli mountain. So we are going to show, I am going to show all these things. So I have already given you lot of mountains, so I think you have mapped. Okay, so I have given all this mountain to all of you. So you can see this is called Rockies mountain. It is in the North America. This is called Rockies mountain. So is it visible? This map is visible to everyone. Yes, it is visible. So it is Rockies mountain. So this is called Rockies mountain of North America. This is called Andes mountain. You can see this is the largest continuous mountain. Longest, not largest, it is the longest mountain. You can say longest continuous mountain is Andes. Okay, so next here it is the Himalaya, the mighty Himalaya here. Then it is Altai mountain, Karakoram mountain, Zagros, Taros. So the Turkey is having two mountains. On the north it is Taros and on the south it is Zagros. So this is called Atlas mountain on the northwestern part of Africa. So this is called Pyrenees, this is called Apennine, this is called Alp, and this is Scandinavian, the fold mountain. And here it is the Ural mountain. Ural mountain lies in the Eurasia between Russia and Europe. Okay, and one important mountain that is found, these are the fold mountain we found on the eastern side of Australia. This is called Great Dividing रेंज, क्या उसको बोलते हैं हम, ग्रेट डिवाइडिंग रेंज माउंटेन. सो नेक्स्ट इट इज ड्रैकेनबर्ग माउंटेन. ठीक है, आई थिंक दीज आर फ्यू माउंटेन. दिस इज कॉकासस माउंटेन, तियान शाह. So these are the mountain you have to map. How you are going to map? So you can download the Google Earth. I have downloaded that, but it is not yet working. This is Google Earth. You can download. This is Google Earth. So it is not working as of now. I don't know why it is not working. Yes, it's working. I think something we have to work on this. It is not working now. So I'll make sure that it's after this class it will work. So that we can have direct discussion of all these things. Chalo. Just now I have downloaded to show all these maps. Please use your Google Earth and find all this location. So after seeing the fold mountain, we have seen different types of mountain. One is fold mountain. Second type of mountain that we are going to see, this is called block mountain or this is called fault mountain. क्या उसको बोलते हैं, fault, F-A-U, fault, F-A-U-L-T, fault mountain. What is fault mountain? Fault mountain happen because whenever, let's say, you can see here there is a block, single block was there, earlier the single block was there, ठीक है, and because of this you can say the tensile strength, it is pulling on the both sides, so these two blocks are falling below, and if you are standing here and seeing at the top, it look like a mountain. This is called fault mountain. It is because of tensile. आप जब एक दो रबर को लेके खींचोगे, एक टाइम पे वो ब्रेक डाउन हो जाता है. Same thing happen with the earth surface. Whenever you are stretching on the both side, so there will be falling of this portion towards below, and this is what, if you are standing here and looking on the here, so it will look like a mountain, and this mountain is called fault mountain. Good morning everyone. Yes, very good Alex, very good morning. चलो बहुत बढ़िया है. Now you all are there. चलो आगे बढ़ते हैं फिर. So yes, so next is the block mountain originate through faulting, the process where, ठीक है. So block mountain origin through the faulting. Faulting means when we are stretching the rock on the both side, then some portion will be fall down. That is what led to the formation of fault mountain. And you can see here, whenever we are stretching, and that is what led to the slipping. And if you are standing here and look, you will look like a big mountain you will find here. Sometime also excessive compression force, when we are compressing, let's say we are compressing this on the both side. If we are compressing on the both side, one portion may be climb over another. So if one portion may be climb over another, if we are pushing the block on the both sides, so for example, if we are pushing like that, you can see here, this is the remote, I think this is the remote. If both are pushing, sometime one rock might climb over another like that. In this case, what will happen? This is also, if you stand here and look, also it look like a mountain. Okay, so this is what also happens. Okay, this is called reverse fault. Okay, normal fault is happen because of tensile strength, and reverse fault occur because of compressions. Okay, sometime strife, the strike slip fault is also happen. For example, if both these plates are pushing one another, instead of anyone rising and falling, if they are moving like that, this is create a fault. It's called slip strike fault. And if you stand here, look, it will look like a mountain. It will look like mountain here also. So there are three types of fault mountain. There are other category as well, but this is what you have to understand. No need to know more than that. Okay, so next is this uplifted portion. The uplifted portion is called horst. For example, I am going to show you, and this subsided portion is called as graben or rift valley. So let's see that in this diagram. This is what called horst, H-O-R-S-T. This is what called horst, and this subsidence or the ditch portion is called graben or rift valley. ठीक है, so this is what called Rift Valley. This down portion is called Rift Valley graben and uplifted portion is called Horst. I think already we have seen in fold and fault mountain yesterday only. So tell me, this portion is called what? This is what? And this is what? Which portion is called syncline and which portion is called anticline? So tell me in the comment box. Now chat is open, so if you think you know, then please let me know. In fold mountain, the crust, the rising portion is called what and trough portion is called what? It is syncline or anticline. And please देखते हैं आप कितने लोग आप लोग पढ़े हुए हैं, ये मैंने कल भी बताया था आपको. ठीक है, आगे बढ़ते हैं. ठीक है, so you can see the tensional force pull the crust apart and fault fracture develop normal fault. ठीक है, so what kind of fault it is given? Some of the examples of block mountain, that we are found in different region. So first one is Sierra Nevada. Sierra Nevada कहाँ है? It is in USA, California. So tilted block mountain with steep eastern face. So please remember this name of this mountain. So there can be question, they can give you the list of mountain and they ask you which type of this mountain is consisting of which type of mountain. ठीक है, so they can also give list of this, they can give list of 1, 2, 3, 4, 5, 6 and then say how many of above are fault mountain, how many of above are fault mountain. So if you know about this location, then only you can answer. So same kind of question already they have asked in multiple occasion, or else in the mains examination you have to write that also. ठीक है, so next is Black Forest. Where you find it? Found in German. So the classic Horst and Offer Rhine graben system. So Black Forest is also classic example of that. Next is Vosges mountain of France. So this is on the flank of Rhine Rift Valley. So Herz mountain in Germans also, Baikal mountain in the Russia and Drakensberg mountain in South Africa. So these are few examples of fault mountain. So hope you are able to understand, or if you have any doubt please let me know. जो भी डाउट है चार्ट ओपन है, मैं भी हमेशा अवेलेबल हूँ. यू कैन नोट डाउन माई नंबर इफ यू हैव एनी डाउट. यू कैन 7217630385. वट एवर मे बी योर डाउट यू कैन रीच आउट टू अस. ओके, चलो आगे बढ़ते हैं. ठीक है, सम ऑफ द एग्जाम्पल्स. देन आप बोलोगे कि सर आपने तो वर्ल्ड का बता दिए, बट व्हाट अबाउट इंडिया? इंडिया का भी तो बताओ. चलो कोई नहीं, बता देते. इंडिया में कुछ माउंटेन्स हैं जिसको हम बोलते हैं फॉल्ट माउंटेन. सो फॉल्ट देखो, इंडिया इज लार्जली डोमिनेटेड बाय फोल्ड माउंटेन्स एंड प्लाटूज, बट ब्लॉक फॉल्टिंग प्ले सिग्निफिकेंट रोल इन सम रीजन. फॉर एग्जाम्पल सातपुरा रेंज वी आर गोइंग टू सी लिटिल बिट ऑफ बिलो. सो दिस इज ऑल्सो ए fault mountain. Vindhya range, Narmada Rift Valley and Malwa Plateau. So these are the 4 example of fault mountain we have found in India. So let's see about all that, whatever I have discussed here it is given. So you can see example of block mountain. So first one is Sierra Nevada, it is in USA, California. You can see here it is the Sierra Nevada. So I have already mapped for you. Vosges, Germans, Herz mountain. The next is Great African Rift Valley. This is a classic example of faulting. I think you know. If you see here, even available in the Google Earth also. So I am really sorry I am not able to show you about all these things. So please read properly. Tomorrow after starting of the class, I will do all this mapping and show you all how you are going to do that in Google Earth. Okay. Here it is the Salt Ridge. So these are the few block mountain where I have shown you. So next is about India. So if you see about the block mountains of India, you will find, because you can see some of the mountain. This is called Aravalli mountain, this is called Vindhya mountain, this is called Satpura. In between Vindhya and Satpura there is a faulting. So this is Vindhya mountain, this is Satpura mountain, and between two mountain, this is two mountain, there is a faulting happen. This is Horst and this is, there is a graben in between two. These are Horst and this is what called graben, and through this graben Narmada river is flowing, and through this Rift Valley Narmada river is flowing. So there is a ditch like this in between two mountain, and that channel being used for Narmada to flow there. So hope it is clear. In case you have any doubt, I am always there, so please reach out to me. And you know, those who are preparing, so this foundation class is continuing. You can join our foundation class. So this is one stop solution, not only the classes but also the support, mentorship, test series, everything you will get. Okay. So next is about the folding and faulting. So what are the difference between the folding and faulting? So we have studied the folding, now we have completed also the faulting. So fold are bent in the rocks that are due to compressional force. Okay, whenever you can take about the folding, whenever two plates they are coming together, they are converging to the together, they are meeting here, and then gradually because of pushing they are rising upward and forming a fold mountain. And why they are forming fold mountain, what are the condition, we are going to see gradually. Don't worry about that, I am going to explain that. Now for time being you should know this much. Okay. The folding occur when compressional force is applied to the rocks that are ductile or flexible. This folding happen in case of flexible or ductile rock. It will not going to happen all rocks. Okay. So only in case of ductile rock there will be folding happen, otherwise this rock may break down and lead to the formation of fault type of mountain. Okay. So you can see the fault are due to tension force along which displacement of rock takes place. If there is a complete rock, let us say this is a pure rock and they are moving apart, then when they are moving apart the middle portion will be fall down, that is what led to the creation of faulting. Rift Valley, classic example of Rift Valley is African Rift Valley. So fault occur when force operating in the opposite direction leads to the tension and result rock develop cracks and fissure. I think if you see about African Rift Valley, you will see there is a big fissure happening there. Fissure means there is टूटना, fissure मतलब टूट जाना. ठीक है, जो आप देखें ना क्रैक्स, अगर कोई ग्लास में पत्थर फेंक तो बहुत सारे क्रैक्स आ जाता है. दिस इज व्हाट कॉल्ड फिशर. ओके. सो rocks that lies deep within the crust and therefore are. So here rocks layer are near to the surface and not under. जरूरत नहीं है, बस आप इतना आपको पता होना चाहिए. The folding are happening whenever buckling of earth surface and faulting are happen when they are moving. So that is all, let's say, breaking of earth surface and folding are generally found, you know, the reason of. चलो उसको बाद में बात करेंगे, अभी आपको कन्फ्यूजन हो जाएगा. जैसे मैं प्लेट को थोड़ा डिटेल में पढ़ा दूंगा तो आपको ये भी समझ में आ जाएगा. आई विल एक्सप्लेन ऑन दैट टाइम. ठीक है. सो वी हैव सीन two types of mountain, one is fault mountain, another is fold mountain. ठीक है. So now we are going to see about few theory of continental formation. So big question that might be coming to your mind कि जो continent है, like you know different continent like North America, South America, the Africa, Eurasia. So all this continent we are seeing how they are formed, कि कैसे formation हुआ, इसके बारे में बताओ. So there are a lot of geographer, geologists who have tried to explain that through their theories, and we are going to see that. So first theory that we are going to see is about continental drift theory. देखो, we are going to see lot of theories and not a single theory is able to explain until the plate tectonic theory. ठीक है. So each and every theory they provide some partial informations to you, but at the end you will get complete information about this through the plate tectonics theory. So till the plate tectonics theory you will have a lot of confusion. I know that you will not able to understand why this is happen, because this theory they have proposed but not able to explain why this is happen. They just give a proposed theory, but at the end by using all this evidence we have developed the the plate tectonics theory, and this plate tectonics theory answer to all your doubt at the end. So that means during this process of explaining this theory you will might not able to understand something. Have the patience, at the end of plate tectonics theory everything will be clear. Okay. So this 3, 4, 5 theory that I am going to discuss one by one today class. Please have patience. Lot of question in your mains, prelims are asking directly from you, from these theories. Listen very carefully. Okay. So a big question, you know, one geographer, so they try to, you know, connect. This is Africa, this is South America and North America, and this is Eurasia. They try to connect these different portion of the landmass and found that they are perfectly matched. Okay. So that is what led to they propose a theory that the earth current position of the landmass on the earth, the current position of landmass on our earth or the world we are seeing, it is not static, so they are keep on moving from one positions to the another positions. For example, they have explained that initial this position, and later on they shifted to this position, and again they shifted to this position, and then this position. And by using all these things, so the geographer proposed a theory. This theory, name of that theory is called continental drift theory. What is the drift? अगर आप पानी के ऊपर कोई एक थर्माकोल या फिर कोई लाइट चीज़ें डाल देते हो, वो क्या करता है? ड्रिफ्ट, धीरे धीरे करके फ्लोट करके मूव करता है. दिस इज व्हाट कॉल्ड ड्रिफ्टिंग. ड्रिफ्टिंग मीन्स मूविंग वेरी स्लो. ठीक है. सो दिस थ्योरी बेसिकली ट्राई टू एक्सप्लेन दैट द कॉन्टिनेंट, लाइक different landmass that we are seeing, be that Africa, Australia, India, they are not static, they are moving their position from present to different location. Now India is having different border, we don't know, maybe in future India might be in different place. Okay? So earlier you can see here the Africa and South America are very close, and this is India. India is in near to the Arctic, but now if you go to the present position, India is here. Here it is South America, this is Africa. You can see clearly the position of Earth are keep on changing. So that is what led to the proposal of the theory, name is called continental drift theory. चलिए आगे बढ़ते हैं. So this theory is called continental drift theory. So this is being proposed in 1912 by German meteorologist Alfred Wegener. This theory, the continental drift theory, is being proposed by Alfred Wegener. देखो sometime UPSC may ask the question about the theory, and that is being proposed by which person. For that reason, you have to understand the theory, and it is being proposed by the name of that person. Okay? So Wegener sought to explain the present of distribution of continent and ocean, different time scale. So according to the Wegener, what Wegener says that, you can watch this diagram I am explaining. So according to the Wegener, so initial stage, so there is a super landmass. Initial stage, all the land of world, they are at one place. This super landmass is called Pangea. क्या उसको बोलते हैं? Pangea बोलते हैं. The super landmass is called Pangea, and this Pangea is surrounded by big ocean. This Pangea is surrounded by big ocean, that is called Panthalassa. क्या बोलते हैं उसको? Panthalassa. Panthalassa. So नीचे है, आपको दिख जाएगा, don't worry. Already I have everything is written in the notes. So this is called Panthalassa. This is called Pangea. The big landmass is called Pangea, and it is surrounded by big ocean is called Panthalassa. But they are started, मतलब वो ड्रिफ्टिंग करना शुरू किया. All are moving in different direction. The northern portion they cut out and move towards north. This portion they cut and move towards north, and this is called Laurasian. The northern portion, that is the Eurasia and North America, they are cutting and moving towards north, led to the this landmass is called Laurasian, and southern portion is called Gondwana. The southern portion, like this portion they are moving south, and this portion is called Gondwana, and there is a ocean that is formed in between them. It is called Tethys Sea. Tethys Sea, क्या था वो? Tethys Sea. So this Tethys Sea present the Mediterranean Sea that we are seeing. It is part of the Tethys Sea. I am explaining, don't worry. I am giving you some of the clue. Okay dear, I'll keep the background white from tomorrow onwards. Actually I am keeping this background this little bit of dark color because it is not taking the image properly, because this background I supposed to take in light color, but you know white color is creating lot of reflection. That is the reason I am taking. Okay, आगे बढ़ते हैं. चलो. So this is what the third stage. You can see this is in 225 million year ago. So big landmass is called Pangea, and is surrounded by big ocean is called Panthalassa, and there is a breakdown. Northern portion is called Laurasian, and southern portion is called Gondwana. Okay, and this question already UPSC asked in your previous question. So what is continental drift theory, and provide some of the supportive argument. Already ये question पूछा गया है, ठीक है. So you have to explain that. Next you can see the Northern America and Europe, then South America, Africa, here it is India, Antarctica and Australia. आप सोच सकते हो हमारे पास चाइना के साथ कोई border ही नहीं था. Now we are having border with the China, and all this geopolitical tension is there. So again then there is a further movement, that is what led to the present condition we are seeing. And this is not the final position, maybe later on 100 million year ago something different might be happen. So it is to be seen. So it is believed that after some time there is a rift valley happening in the East Africa. So this portion might be cut off from rest also. चलिए हम पढ़ते हैं अभी. So this continental drift theory, it is being proposed by, this continental drift theory is proposed by, कौन propose किए थे? जर्मन मेट्रोलॉजिस्ट अल्फ्रेड वेगनर उसको propose किए थे. And this try to explain that in historical geological time scale the continent are not static, they are keep on moving. So dear student, hope everything is okay, my audio video everything is okay, so please let me know if you are facing any issue. ठीक है, चलो. So you can see according to this Wegener theory, all the present day continent were once part of the single supercontinent, and that is what called Pangea. I have already explained to you. Meaning all earth. What is the meaning of Pangea? That means all earth. This landmass was surrounded by vast big ocean. This is called Panthalaza. Panthalaza. Big ocean is called Panthalaza. It is observed that continent were break-offs. So Pangea initially split and drift and divided into Laurasian, that is the northern portion of the hemisphere is called Laurasian and southern portion is called Gondwana. Over the period of time, the Laurasian and Gondwana further breaks into form different landmass. Okay, so this Wegener theory challenged the idea of static continent. So before that it is believed that the continent, the position are always fixed, but this theory challenged that the continent are not always fixed, they are keep on shifting with a different time. Okay, so it laid the foundation for plate tectonics and transfer our understanding of earth dynamic cross. So from here we can see our continent are not static as we are currently seeing in our map, so they are keep on changing. So this is what giving us an idea. थोड़ा सा पानी पी लेते हैं. ठीक है. So next thing is that so after this theory is being proposed by Alfred Wegener, so people start questioning कि ऐसा कैसे आप बोल सकते हो. आप अगर ऐसे बोल रहे हो then provide us the evidence कि कैसे हुआ, evidence दो. So to provide this evidence, so Alfred Wegener provide lot of evidence. So what are that evidence? One by one we are going to see. The first evidence that is being provided by Alfred Wegener is called matching continent. That is what called matching continent. So if you see this Africa, the portion of Africa is perfectly matched, the portion of the Africa is perfectly matched, this landmass is perfectly matched with that of the Africa. If you see Antarctica, all these things is also perfectly matched with Australia, India, you can see here perfectly matched. And this is what called jigsaw fit. उसको क्या बोलते हैं? Jigsaw fit. You can see each and everything is fit perfectly within their site. ठीक है. So this is what, if everything is not together, how come they are going to fit? आप एक काम करो, एक कागज को फाड़ लो मल्टीपल पीसेस में. आप जब ज्वाइन करते हो ईच एंड एवरी जो टीयर का जो साइज है सबके साथ मैच कर रहा है, उसका मतलब क्या है? सब एक पार्ट होंगे कभी ना कभी ना. दिस इज व्हाट फर्स्ट सजेशन दे आर सेइंग. ठीक है. यू कैन सी दे आर on without having any error, they are perfectly matching with one another, led to the belief that they are once the part of single continent. So next one is rocks of same age across the ocean. So if you find here, देखो, if you see just a second, I am showing you. One second. Yes. So they have taken, the geologists have taken the rocks. देखो, they have taken the age of rocks from here, age of rocks from here. They have taken age of rocks from here, and when they all are part of a single continent. For example, whenever they are together, they have taken rock sample this location somewhere from here, here and here, and they have found that each of this rock they are exactly at the same age. So it is not possible if they are at the different landmass, they should have the same age rock. कभी हो ही नहीं सकता, क्योंकि this rock might be created different age, different, and same age indicate that all these rocks are formed at the same time when they are part of single continent. If rocks age of this Africa, not this region are showing same, so that means they are part of same continent. Okay, so second evidence, so you can say age of rocks. So rocks of same age across the ocean. So the radiometric dating revealed that rocks formation on the opposite side of the oceans, Eastern, South America, Western Africa, are similar age and composition. So that means they are share the same geological history. Chalo, so next is fossil distribution. So this is also very important. You can see how the fossil distribution is also helpful. You can see there are few, you can see this type of fossil is only found in this region, this Africa and South America. Nowhere in the world you find this kind of fossils. So it is not possible for this small animal to cross from America and reach Africa through this South Atlantic Ocean. It is not possible for them. It's a vast ocean, and it is only possible if this landmass is connected and there is a similar biodiversity, similar ecosystem. So this animal can move from one location to the another location. Same thing, you can find one particular species is only found in this location, and this is possible only if they are connected and having together. Otherwise it is not possible. It is not possible to find same kind of species in South America, Africa, even in the Australia. It is not possible because they are having unique environment. It is only possible whenever they are connected. They are connected and they are having together in a single landmass. So this fossil evidence, you can see one more species are found in Africa, India and Antarctica, only is this location. So it is not possible for this small animal or small species to cross this vast ocean and reach in new continent. This finding of the fossil also show that all our continent are once joined and together. चलिए आगे बढ़ते हैं. So I am going to give you the question. So please after at the end you have to write and submit. ठीक है. So as time proceeds, so it is, this course is not only about teaching. This course is a package. So I am going to give you, in this course we are going to give you the lot of prelims questions. So you have to practice. We are going to give you lot of mains questions. So you have to practice and submit. Okay. So and the notes I think I will provide to you today only. So next is tillite evidence. So what do you mean by tillite or glacial deposit? So you can see here. देखो, you can see here. So all these tips, I think I am showing the earlier map. So it is going to be very clarity. You can see here in this map, in this southern, this is what called South Pole na, मतलब somewhere around the Antarctic Circle. So here you can see on the tip of South America, the South Africa and Antarctica, India, Australia. So there is a deposit of glacial deposit. So this is glacial deposit found. If you see present comparison, it is not possible to found glacial deposit on Kanyakumari, Kerala regions. Not possible to found glacial deposit in South America, sorry, South Africa and America, Australia, because they all are in the tropical region. So how come a tropical region we can found glacial deposit? It is possible only when all these landmass are once located on the near to the South Pole. So if they are located on the South Pole, so they gradually move towards different direction and reach present position. Okay. So this glacial deposit also support the argument of continental drift theory. So next one is about the placer deposit. So what do you mean by placer deposit? So placer means rich in minerals, so heavy metals. For example, inside the rock, so there are some heavy metals like silver, gold. So they start deposit. They start, देखो, rocks can easily erode and run away, but the heavy metals cannot be move away. I think आपने देखे होंगे गोल्ड को ऐसे पानी में करके गोल्ड एक्सट्रैक्ट करते हैं from sand. Why? Because gold is heavy metal. It cannot be washed away by water easily, so it settled down. So this is what called placer. So there is found that in Ghana coast, there is a rich gold placer is found on the Ghana coast. अब जो घाना एक कंट्री है उसका कोस्ट में बहुत सारे गोल्ड का छोटे छोटे पार्टिकल्स मिलती है. लेकिन विदाउट हैविंग इट सोर्स रॉक, लेकिन वहाँ पर कौन सा सोर्स से वो आया हमें नहीं मिलती है, लेकिन उसका सोर्स कहाँ मिलती है आपको, दिस डिपोजिट मिनरल्स their source rocks is found from the Brazil plateau. I am showing in the map, you will understand better. देखो, this is the घाना कोस्ट, ठीक है, देखो दिस इज द ब्राजील कोस्ट, हियर वी फाउंड लॉट ऑफ प्लेसर डिपोजिट, हम क्या हमें मिलती है, बहुत सारे गोल्ड पार्टिकल्स मिलती है, दिस घाना रीजन लॉट ऑफ गोल्ड पार्टिकल्स आर फाउंड, बट हमें उसका ओरिजिन कहाँ से हुआ, कौन सा रॉक से आया वो नहीं मिलती है, और रॉक्स आपको कहाँ मिलती है, दैट कैन फाउंड इन द ब्राजील रीजन. सो इट क्लियरली वी कैन सी दैट दिस landmass was once part of together, so that this rocks eroded and all these sediments of silicon they wash away, but all this gold are deposited there. So this is what called placer deposit. Okay, ठीक है, you can see this is what the evidence that supporting the continental drift theory. So there can be questions, what is continental drift theory, and provide some of the evidence that support the continental drift theory. So this can be your 10 marker question or 15 marker question by adding also the challenges. So this can be a 15 marker questions. So after giving this theory, जब आप बोलते हो ना आपका लाइफ में कभी कुछ अच्छा सक्सेस आप देखो, इन योर लाइफ वेन एवर यू बिकेम सक्सेस एंड अचीव समथिंग, सो पीपल स्टार्ट क्वेश्चनिंग यू कि आपने कैसे कर लिया, ऐसे कैसे हो गया. सो सेम थिंग हैपन. So whenever this theory is proposed by Alfred Wegener, so everyone start questioning कि आपको कैसे पता चला, अगर पता चला तो बताओ, what are the forces behind this movement. ये जो कॉन्टिनेंट को बिग कॉन्टिनेंट लाइक यू नो अफ्रीका, big continent like North America, South America, it is being pushed by some force from one place to the another place, then what are the forces, what are the mechanism behind this. And at that time Alfred Wegener is not having any idea, fails to give answer to this question. So that is what led to the failure of this continental drift theory. But the idea given that there is a floating of continent, moving of the continent from one position to another position, driven the curiosity of the people. People started thinking, people started realizing and questioning, and that is what led to the gradual development of other theory like sea floor spreading theory, plate tectonics theory, and ultimately plate tectonics theory helps to explain everything about how this has happened and what are the reason behind it. Okay, the fault mountain, the fold mountain, all these things, I think we have a lot of confusion. When we are going to see about this plate tectonics theory, everything is going to clear your doubt. Just give me 1 minute, I will take a little bit of water. I will come back. Okay, so now I think it's audible to everyone. Okay, चलिए आगे बढ़ते हैं फिर. So yes, so whenever people questioning about the mechanism and force behind this movement, so Alfred Wegener try to explain the mechanism. So first one is he saying about the pole freeing or centrifugal forces. I think आपने एक होती है ना एक टॉय चक्री होती है जिस पे आप ऐसे ऐसे बैठ के हम सब घूमते रहते थे बचपन में, याद होगा ना वो. लेट्स से इट इज़ रोटेटिंग. अब मैं आपको बताता हूँ, आपको समझ में आएगी. लेट्स से आपने ऐसे चक्री में बैठे होंगे जो घूमता रहता है ऊपर, ऐसे ऐसे घूमता रहता है. अगर आपने बैठे हुए हैं एंड व्हेन एवर इट इज़ मूविंग वेरी फास्ट, हमें क्या लगता है, हमें बाहर की तरफ फेंकने का कोशिश करता है, ऐसे बाहर की तरफ हम उड़ के जाते हैं ना, ऐसे बाहर की तरफ शिफ्ट करने का कोशिश करता है. व्हेन एवर यू आर मूविंग इन ए हाई टर्न, आपने अगर कोई रेस चलाते हो सर्कुलर ट्रैक में, आपको बाहर की तरफ धकेल देने की कोशिश करती है. दिस इज व्हाट कॉल्ड सेंट्रीफ्यूगल. सो इट ट्राई टू फोर्स अवे, सो अकॉर्डिंग टू दिस pole fling force, so it is saying that whenever you are moving or rotating in a particular direction, so this try to move outside, this force try to move outside. So this force actually help, this pole actually help in movement of continent. So this is what called pole fling force, ठीक है. So this is what given by the Alfred Wegener. जब आप कोई चक्री में बैठ के घूमते हो आपको क्या फील होती है, बाहर की तरफ धकेल देती है. सेम थिंग हैपन इन द अर्थ, व्हेन अर्थ इज रोटेटिंग वेरी फास्ट, so there is a centrifugal force. Centrifugal force try to move outside, and because of that move, so it try to pull all this continent in different direction. This is being given by the Alfred Wegener, but some scientists they calculate and clearly prove that this force is not enough to drive such a big continent like Africa, like America, North America, South America. So this argument is failed. So you can see earth rotation on its axis generate a centrifugal force. Centrifugal force means when anything is rotating like that, so there is a outward movement. For example, आपने एक ले लो, एक कोई स्टोन ले लो, स्टोन के साथ एक रस्सी लगा लो, ऐसे ऐसे घुमाओ, घुमाने के टाइम पे क्या होगा, रस्सी हमेशा बाहर जाने का कोशिश करेगा. दिस इज व्हाट कॉल्ड सेंट्रीफ्यूगल फोर्स. एंड दी जो स्ट्रिंग आपने लगाया, दिस ट्राई टू कंट्रोल इट, दिस इज द फोर्स दैट इज इम्पोजिंग ऑन द स्टोन इज कॉल्ड सेंट्रीपिटल. ठीक है, दो तरफ की फोर्स होती है एंड दे बैलेंसिंग आउट. दिस इज व्हाट कॉल्ड सेंट्रीफ्यूगल फोर्स. एंड दिस व्हेनेवर यू आर अटैचिंग ए स्ट्रिंग, सो इट्स ट्राई टू ब्रिंग टू द सेंटर. आपने यहाँ खड़े हो, लेट से आपने यहाँ खड़े हो, घुमा रहे हो उसको, ऐसे घुमा रहे हो, सो द स्ट्रिंग इज ट्राइंग टू पुट ए सेंट्रीपिटल फोर्स, दैट मीन्स इट इज टुवर्ड सेंटर. मैं अगर ऐसे ऐसे घुमा रहा हूँ, द स्ट्रिंग से बाहर की तरफ जाने के लिए जो फोर्सेस लगती है उसको बोलते हैं सेंट्रीफ्यूगल फोर्स, एंड द स्ट्रिंग से मेरे तरफ एक फोर्स आती है उसको बोलते हैं सेंट्रीपिटल. सो वी आर गोइंग टू सी दैट ड्यूरिंग द टाइड्स ऑल्सो. सो कोई इशू नहीं है, थोड़ा पेशेंस रखो, वो भी समझ जाओगे. सो फ्रॉम पोल्स towards equator. So Wegener believed that this force contributed to breaking of the Pangea and equatorward drifting of the continents. He termed this as a pole fling force. क्योंकि all this, why this is called pole fling, because this continent they are moving from pole towards equator, so they are called pole fling force. ठीक है, so they pushes landmass away from rotational axis. So when scientists or geologists they cancel or reject this argument, at that time the Wegener say that this is happened because of tidal forces. So tidal force is because of gravitational pull between earth, sun and moon. So Wegener say that this has happened because of gravitational pull. So again some geologists they count that the gravitational force of sun, moon, earth is not that enough so that they can keep everything together. Okay, so you can see the Wegener also proposed that influence of tidal force resulting from gravitational pull between moon and sun. So we are going to see this tides in a separate class in depth, just for time being understand that. Okay, so he uses concept of westward drift of America contributing to lunar solar drag. But this mechanism, but some scientists clearly proven that the tidal force or the gravitational force of sun, moon and earth interaction is not that enough to pull this big continent. Some scientists even proven that if the tidal force is so much, in that case it can stop the rotation of earth itself. ठीक है, चलो. So this tidal force combined with centrifugal force thought to act as a driving mechanism for continental drift. So they are proposing that only. ठीक है. So what are the limitation of this Wegener explanation? Though Wegener correctly proposed the continent movement but could not provide convincing mechanism of how they do so. No doubt the Wegener, the theory they have proposed, the idea they have given and the evidence is given, they are perfectly matched, but the Wegener is not providing the idea of what driving the continent. So he is not able to describe the driving force or driving mechanism behind this the movement. So the pole fling force was too weak. It is not that big, it is not that huge amount that can pull or push a continent. Next is tidal force should not account for the scale of continental movement. Even the tidal force is not that big. Even you can see the tidal force is not able to generate, the amount of tides generated by the tidal force is negligible. Even the big lakes you don't find any tidal force. So it is so weak that it cannot move the continent. Okay. So next is, as a result of this theory, faced strong criticism from scientist community during his time. So because of this criticism and not able to explain the driving mechanism behind this continent movement, so this theory is failed. ठीक है, though this theory, देखो what kind of conclusion you can write in this question, no doubt this theory is failed, but at least this theory raised the curiosity on the minds of the scientist or geologist or geographer to think something unique idea, and that unique idea later on helps to find what you can see here. Despite these flaws, Wegener theory laid the groundwork for modern plate tectonics theory, which emerged in 1960s, and it tried to give all this answer why fold mountain is happening, why fault mountain is happening, why there is a earthquake, why there is a volcanism. Everything is answered by this plate tectonics theory. Hope it is clear. So if you have any doubt, please let me know. अगर आपका कोई सा भी डाउट है, please let me know. कोई सा भी डाउट है regarding this plate tectonics theory and all, so sorry, regarding this continental drift theory, please let me know. कोई डाउट है तो आप पूछ लीजिए. येस, आई विल कीप दी बैकग्राउंड वाइट फ्रॉम टुमारो ऑनवर्ड. ठीक है, थोड़ा सा भी मैं सेटिंग में चल रहा हूँ, इसका थोड़ा सा लाइटिंग फाइटिंग का ठीक हो जाए, फिर सब कर लेंगे. डोंट वरी, थोड़ा बस टाइम दे दो. दिस इज़ ऑल अबाउट थोड़ा सेटलमेंट का, थोड़ा ये सब ठीक ठाक हो जाएगा, फिर कर लेंगे. चलिए आगे बढ़ते हैं. सो नेक्स्ट इंपॉर्टेंट थ्योरी दैट वी आर गोइंग टू डिस्कस इज कन्वेक्शन करंट थ्योरी. नेक्स्ट जो इंपॉर्टेंट थ्योरी हम डिस्कशन करने वाले हैं वो है कन्वेक्शन करंट थ्योरी. सो व्हाट इज convection current theory? I think you already know. This is what the interior diagram of earth. So earth is not single layer, it is consisting of concentric layer. This is inner core, so this is solid, this is outer core, and outer core is liquid. ठीक है, then this is what called upper mantle, so this is what called lower mantle, this is called asthenosphere. This is what called upper mantle, and sorry, this is called lower mantle. Sorry, this is called lower mantle, this is called upper mantle, and this layer is called, this top portion of this layer is called lithosphere. ठीक है, so this is what I am writing. देखो, this mantle. This mantle is divided into two layers. The bottom layer is called asthenosphere. This bottom layer is called asthenosphere, and top layer is called lithosphere. ठीक है, this top layer is called lithosphere. And this bottom layer is called asthenosphere. Asthenosphere is in plastic or semi liquid state. Asthenosphere क्या है? Semi liquid state में है. So because of that, this lithosphere is floating above the asthenosphere very freely. ठीक है, so this is what the context so far. So now how they are using this concept to explain the convection current theory. I think you can see here. You can see here. So because of this heat, so because of, you know, whenever this is quite heat, this is also quite heat. I think I am giving an example. Let's say take a pot. आप एक pot ले लो और बर्नर के ऊपर लगा के उसको आग लगाओ, जलाओ, तो क्या होगा? There will be rise of water, fall of water. Water will be rise and fall. There will be circular motion. Same thing happen inside the earth. So whenever there is a heat that is being supplied from core to mantle, so whenever heat is coming, so they will find some place where they can rise. They can rise here, and then whenever they rise here, they will break the crust, and there is a volcanic eruption will happen. So whenever the heat try to come out through this mantle and crust, they will break the continent and try to move this continent on the both side and come outside, and then gradually this plate they solidify to form new continent, and then they push this lithospheric plates on the both side. Okay, and this lithospheric plate will be move and then move, and they will come inside, and again here they are coming inside the earth, and we know that as we move deep inside earth there will be increase in temperature, and because of high temperature this plate will be melted down and again form the magma, and then again it will be move upward to form new continent move, and they are moving like a continuous cycle. So this is what called convective cells. Convective cells, it is forming a continuous cell. This is what called convective cells. Let me explain one more time so you will have idea. This theory is very important for understanding of plate tectonics. What happened? देखो, we know that the mantle is divided into upper mantle and lower mantle, and further the upper mantle is divided into lithosphere and asthenosphere. The upper portion is called lithosphere and bottom portion is called asthenosphere. ठीक है, so I am dividing, this is what called lower mantle. ठीक है, this is what called lower and this is what called upper mantle. क्या इसको बोलते हैं? Upper mantle, and the top portion of the upper mantle is called lithosphere. इसको हम क्या बोलते हैं? lithosphere बोलते हैं. And bottom portion is called asthenosphere, and we know that asthenosphere is a soft layer, soft plastic layer on the top of the asthenosphere. Lithosphere is actually moving. Lithosphere is moving on the top of the asthenosphere. So we know that, and you know, because of excessive heat that is being supplied from core, so it try to move outward. It try to move outward and find a weak place. The reason where there is a weak, they come out on the surface and form a new continent. When something is come out, जैसे ये दोनों के बीच में अगर कोई आएगी तो क्या करेगा? दोनों को स्प्रेड करने का कोशिश करेगा. Same thing happen. This pushes this continent on this direction and this direction. They will move and they will move, they will move and they will move downward here. And once they are moving downward, as you move inside the earth, there will be high temperature, and because of that, this plate will be, you know, this lithospheric plate will be melted down and became converted into liquid, and again it will flow in this way. So this is what the continuous movement is called. This continuous movement is called convection cycle, or this is what called convective cells. Same thing happen this side also na. Okay, so this is what called convective cell theory. चलो मैं आपको अभी एक्सप्लेन कर लेता हूँ. आई थिंक दिस डायग्राम इज क्वाइट, यू आर एबल टू अंडरस्टैंड दैट. ओके, सो दिस थियोरी, हु प्रपोजेस दिस थियोरी इज वेरी इंपॉर्टेंट, सो यू हैव टू अंडरस्टैंड. सो फर्स्ट, दिस थियोरी इज कॉल्ड convection current theory. So convection current theory is pivotal in modern plate tectonics theory. So the modern plate tectonics theory try to explain everything by using this convection current theory. ठीक है, so this is being proposed by, नाम is Arthur Holmes, 1930s. Theory form foundation of the, this theory is the basis for explaining sea floor spreading hypothesis and explaining various geological phenomena such as mountain building, earthquake, volcanic activity and oceanic trenches and ridge formation. How I am going to explain you. So there can be question, there can be a good prelims question by using convective current theory. What are the geological phenomena, what are the geographical phenomena, geophysical phenomena, geomorphological phenomena we can explain. We can explain what? We can explain about mountain building, we can explain about earthquakes, we can explain about volcanic activity, we can explain about oceanic trench, ridge formation by using convection current theory. ठीक है, so this you can see this Holmes proposed later became a cornerstone for development of the plate tectonics theory. There can be question, so which theory is became a cornerstone for development of development of plate tectonics theory. So it is the convective current theory is actually acting like a cornerstone for development of plate tectonics theory. ठीक है, so you can see convection current is a circular pattern of flow within the fluid medium. So earth mantle generated due to temperature and intensity difference. So why, from where this high temperature they are getting? So this core is actually source of all this temperature. So this temperature we are getting, the high temperature we are getting either from the radioactive decay. There are a lot of radioactive material at the core, radioactive decay. So this radioactive material, so they start decaying. So because of that they release lot of energy. So because of that they release a lot of energy, and this energy actually supply all this actions, energy for this action. Second thing is about, you can see, radioactive decay of element like thorium, uranium, thorium, potassium deep in the mantle. Lower mantle is lower than that of the upper mantles. First thing is, second thing is about ठीक है. So we can see all this energy they are getting either from the core, or there is a radioactive decay happening itself in the mantle itself. ठीक है. So these are driving force behind it. Okay. So you can see whenever the rising limb, this is what called rising limb, whenever there is a rising limb of this current, so that breaks this continent into two parts and new continent is formed here, and then the plate is moving this side, plate is moving this side, and they try to collide with another plate, and the plate that is heavy need to be move inside. देखो दो plates अगर collide करते हैं, the heavier the plates always move inside, क्योंकि heavy चीज़ें हमेशा down नीचे गिर जाता है. So whenever this plate is moving, so that is what created trench. जहाँ पर दोनों collide करके एक trench बनाते हैं. From trench means this is a deep, you can say deep area or depth that is found on the either on the ocean or on the land mass, but generally this found in the ocean. ठीक है. So we can say the rising limb near to the formation of new crust, and the plate, they are moving on the both sides, they interact with another plates, and this plate is moving inside the earth, they melt down, again they supply magma, and this cycle continue forever. This is called convective cycle. ठीक है. So this theory actually provide evidence for support or help in plate tectonics theory. ठीक है. So next theory that we are going to see about dynamo theory. Dynamo theory means from where our earth magnetic field is. देखो, our earth is like a perfect magnet. It support it support lot of things. It support the magnetic orientation, and this magnetic field is very much helpful for having life on the earth. अगर without this magnetic field there could not have any life on the earth. Life में earth, देखो earth पे life होना possible नहीं हो सकता है without this magnetic field. ठीक है. सो डायनामो थ्योरी एक्सप्लेन अर्थ मैग्नेटिक फील्ड एज ए रिजल्ट ऑफ कन्वेक्टिव करंट्स. मैं आपको एक बार और समझा देता हूं तो आपको समझ में आएगी. बिफोर गोइंग ऑल दिस थिंग्स, सो मैं आपको एक बार समझा देता हूं कि मैग्नेट होते कैसे हैं. देखो, इफ दिस इज ए मैग्नेटिक मटेरियल, ये क्या है, एक मैग्नेटिक मटेरियल है, हम उस पर क्या देना चाहिए, करंट देना चाहिए. ठीक है. हम उसको क्या देंगे, करंट देना पड़ेगा. लेट्स से आई एम गिविंग करंट, सो इट इज फ्लोइंग लाइक दिस. So there is a right hand thumb rule. If current is flowing like that, then there will be north pole on the top and there will be south pole on the bottom. ठीक है. So we need magnetic material. What we need a magnetic material. Magnetic material plus there will be a current. If we flow a current in a magnetic material, so there will be a magnetic field. This magnetic field will be flow like this from north pole, they will come to the south pole. Okay, very simple. I think you all studied same thing in your 8th, 9th or 10th. So the magnetic field, they will flow from north pole towards south pole like this, like this, like this. Okay, this is the pattern of their flow from north to south. So how this is happen inside our earth? So this is what we have to see. You can see our earth inner core, outer core. We know that outer core is liquid, and outer core, inner core, they are composed of iron, nickel, cobalt. So all are magnetic material, and this is rotating. Whenever this is rotating, and this liquid state of the materials, देखो inner core inner core is solid, outer core is liquid. Whenever they are rotating and whenever you rotate the liquid, liquid will curl like flow like a, आप एक काम करो पानी के अंदर जाके से हाथ घुमाओ तो आपको क्या होगा, यू नो वाटर विल मूव इन ए ईडी, लाइक यू नो एक कॉइल की तरफ मूव करता है. सो सेम कॉइल यहाँ करंट की तरफ काम करता है ना. So already there is a magnetic material, and because of this liquid state, so it gradually move like a ED or a current, and this liquid state is act like a movement of current, and this current is called convection current. So there is a magnetic material, there is a current, so that is what led to the formation of magnet, and this magnetic field of earth is very much helpful to protect life on the earth. How we are going to see, this is what the concept you need to understand. Let's move further. Okay. So dynamo theory explained that earth magnetic field is a result of convection current in molten conductive outer core. So we can say that outer core is responsible for earth magnetic field driven by heat and composition difference. So generate electric current that through electric magnetic induction sustain magnetic field. Okay. So you can see the earth magnetic field is because of outer core. ठीक है. So from where our earth is, like you know, from where inside the earth we are getting so much of heat in outer core, so it is in liquid state, so that means temperature is very high. So from where they are getting lot of temperature because of latent heat of crystallization as inner core is solidified. Okay, first one is because of, second one is about the radioactive decay. So there are some element like potassium, uranium and thorium, so they decay. There are gravitational energy, some of them are called residual energy also. Residual energy means not written here. So earth was part of, देखो earth was part of this, you know, same solar system once, that used to be hot ball, but gradually outer layer are cool down, solidify, but there are a lot of heats trap inside. जैसे आप देखे होंगे ना, कोई एक मतलब मान लो कोई समोसा खाते हो, समोसा आप गरम गरम ला के जब रखते हो तो आउटर लेयर में भी कूल डाउन वेरी फास्ट, बट इनर लेयर में गर्मी रहती है बिकॉज आउटर लेयर इज एक्टिंग लाइक ए इंसुलेटर. ठीक है, तो प्रिवेंट करते हैं. सो दीज आर दी फ्यू रीजन. फर्स्ट वन इज रेडियो एक्टिव डिके, देन रेसिडुअल हीट, एंड थर्ड one is you can say friction, or you can say the core is having intense pressure. So because of that also there is a heat, but no one ever visited the outer core, inner core to judge what are the reasons. So these are expected reason of temperature in this outer core. देखो हमने कभी विजिट तो नहीं किए, ना आपने किए, ना कोई जियोग्राफर किए, सो बट हम एक्सपेक्ट करते हैं ये सब रीज़न हो सकता है. ठीक है, सो डिफरेंट बुक में आपको डिफरेंट रीज़न दिया गया, बट आपको यही लिखना है. रेडियो एक्टिव डिके, रेसिडुअल एनर्जी, टाइडल फ्रिक्शन, सो ऑल दिस थिंग्स आर रेस्पॉन्सिबल फॉर हैविंग हाई हीट. सो नेक्स्ट इंपॉर्टेंट थिंग दैट वी आर गोइंग टू सी इज कॉल्ड मैग्नेटोस्फीयर. सो बिकॉज ऑफ देखो, वेन एवर यू आर पुटिंग ए मैग्नेट, लेट्स से आपने कोई मैग्नेट को यहाँ रख लेते हो नॉर्थ एंड साउथ, and because of that there will be flux that try to flow from north pole towards south pole. It will try to flow, and this is what the sphere of this magnet, this is what sphere of the magnet, if you are bringing any iron within that sphere it will pull towards it. ठीक है, so if you bring any irons or any magnetic material towards this or this, you know, magnetic sphere, it will try to pull towards it. And if you are bringing some charged particle, it also deflect. If you bring some charged particle to this magnetic field, it is going to be deflect. Okay, so this is what property of magnets. So this is what happening in case of earth also. So we are going to see how earth is acting like a magnetosphere. ठीक है, so मैं आपको एक बात दिखा देता हूँ वो डायग्राम, तो आपको बड़े अच्छे से समझ में आएगी. देखो, दिस इज़ आवर अर्थ, ये हमारा क्या है, प्यारा सा अर्थ है. तो अर्थ के अंदर जो हमारा चीज़ें हैं, यू नो, नॉर्थ, दिस इज लेट्स से दिस इज द नॉर्थ पोल, लाइक विल टेक द करेंट कन्वेंशंस. सो फ्लक्स इज मूविंग लाइक दैट, फ्लक्स इज मूविंग लाइक दैट, फ्लक्स इज मूविंग लाइक दैट, एज आई हैव शोन यू, flux is moving like that. Okay, so these are called magnetic field or magnetic field of earth. These are magnetosphere of earth. These are the magnetosphere of earth because of all this internal dynamo effects. So these are called magnetosphere of earth. So what happened? Listen very carefully. So let's say this is our sun. This is, ये जो भाई साहब है इनका नाम क्या है, sun है. सन क्या करते हैं, the sun emit lot of charged particles towards earth. The sun emit lot of charged particles towards earth. You can see these are the charged particles, charged particles, charged particles, charged particles. The charged particles always try to move towards earth, but because of this magnetosphere of concentric layer, so these are acting like a shield and they divert all this charged particle, they divert all this charged particle like this. They divert all this charged particle like this, and this is what helpful for protecting life on the earth. If this magnetosphere was not there, so there is high chances that because of this high energy particles, they can enter into our atmosphere and cause severe damage to the humans also, because they are charged particles, they are radioactive elements also, so they can cause severe harms and life even not possible on the earth surface. Even some of the planets that are very close to the sun, so they this charge, these solar winds, they have taken all their atmospheric gases, but in case of earth this is not possible because of our earth magnetic field. Okay? You can see some of the charged particles also get trapped. Some of the charged particles also get trapped in this 2 or 3 concentric layer. This layer is called Van Allen belt. So while they are repelling some of the when solar wind is there, some of the solar wind try to enter into, and some of them get trapped in this multiple concentric layer. So this layer is called Van Allen radiation belt. वो जो ट्रैप होकर रह जाता है उसको हम क्या बोलते हैं, Van Allen radiation belt. Because of this charge particle is being trapped, so it don't allow further any charge particle, because if it is positive, it don't allow positive to come here. If it is negative, it is don't allow negative charge particle to come here, because positive will be repel and negative will be repel. So we can say Van Allen belt and all this radiation is really helpful to protect लाइफ ऑन दी अर्थ. ओके, चलो आगे बढ़ते हैं. मैं आपको एक बार समझा देता हूँ अच्छे से. From here UPSC is already asking multiple questions, so after this discussion, so you will not have any doubt on this. Okay, so magnetosphere is the region around the earth dominated by its magnetic field, which act as a protective shield against space weather phenomena like solar wind and cosmic ray. So any high energy radiation that is coming towards earth, it is being deflected by earth magnetic field. Earth magnetic field क्या करता है, उसको deflect करके बाहर फेंक देता है. So it protect us from high energy particles. So start from the ionosphere 60 km and extend tens of thousand km into the space. So it is starting from the ionosphere into the space. So they are source of the source of magnetic field generated by electric current in the liquid outer core. So liquid outer core that generated magnetic field, and this magnetic field is flowing from north to south, is responsible for this magnetosphere. Okay, this shape is, its shape is compressed and in daytime. So during daytime there is a sun's, I think we have seen the sun's radiation is there. So because of that, this side there is a compression, but elongated on the night time. When sun's charge particle is not there, so they elongated. Okay? So what functions they do, what are the functions of this magnetosphere? They deflect the solar winds. So these fast moving plasma from sun is deflected around the earth. So when they are deflected around the earth, so it is not allowed to penetrate deep inside the earth. So prevent the atmospheric loss. So without it, solar wind could strip away the upper atmosphere, including ozone layer. So some of the planets, some of our planets, they are very close to us, so they don't have any good atmosphere. Why? Because suns strip away all their atmospheric gases, because they don't have good magnetic field. So this magnetic field helps us to have our atmospheric gases within our earth, and that is very much helpful for having life on this earth. Okay, so one minute. चलो कोई नहीं. So next is a trap particle. So create a radiation belt called Van Allen belt that trap charged particle and protect surface. I have shown you The Van Allen belt, actually that there is a circle portion that trap all these charged particles. Whenever they trap the charged particle, it don't allow another charged particle to come inside. So they protect us further. So this is what called Van Allen radiation belt, is zone of energetic charged particle, most of which originate from solar wind, that are captured and held around the planet by that magnetic field. आपको मैंने दिखाया था, this is what called Van Allen radiation belt. ये कुछ charged particles को स्टोर करके आपने अंदर रख लेता है. So because of that, they don't allow further entering of charged particle from sun. ठीक है. So there are two such concentric tire shapes. So inner belt is 1 to 2 radius, earth radius, and outer is 4 to 7. So this is inner radius of Van Allen belt. This is outer radius of Van Allen belt. Please remember that. So by trapping the solar wind, the belt deflect the energy particle and protect the atmosphere. So we can say that this earth magnetosphere not only protect the atmosphere but also protect life on this earth. So if it is clear, ठीक है, sun's magnetosphere, ठीक है. So sun's, just like the earth is having its magnetic sphere, so there is Suns is also having its magnetosphere. उसको हम क्या बोलते हैं, heliosphere. Heliosphere is vast bubble like region, space dominated by the solar magnetic field and solar winds, essentially forming the sun's magnetosphere. So it extends beyond the Pluto, the planet Pluto. So sun's magnetic field is so vast that it is more than the Pluto's magnetic field. So it acts as a shield against solar system. देखो, there are other galaxies as well. There are other big solar system also. So they emit lot of charged particles toward different direction. Our sun's magnetosphere protect, don't allow all these high radiation charged particles to come inside the solar system. Okay, so deflect and slow down significant portion of galactic cosmic ray. If this galactic cosmic ray is coming inside our solar system, it is going to cause severe devastating effect. It can damage life, it can kill people, it can damage the atmosphere also. ठीक है. So high energy particle from outside the solar system help regulate the cosmic ray intensity and reaching the planets. Okay. So just like our earth magnetosphere, so there is a heliomagnetosphere. Helio means related to sun. So anything related to sun is called helio. इसको हम क्या बोलते हैं, helio बोलते हैं. चलो. So next important thing, I think this colorful, I think you have seen in higher latitude near to the Arctic region, near to the Antarctic region. I think this colorful light you all have seen some movies or something like that. So these are called aurora. These are called aurora. So if it is seen on the northern pole, it is called aurora borealis. If it is seen on the south pole, this is called aurora australis. कैसे उसको याद रखोगे, ऑस्ट्रेलिया कहाँ है, साउथ में है, इसीलिए साउथ को बोलते हैं ऑरोरा ऑस्ट्रियालिस, एंड नॉर्थ में जो होता है उसको बोलते हैं ऑरोरा बोरियोलिस. सो दिस कलरफुल लाइट इज कॉल्ड ऑरोरा ऑस्ट्रियालिस, ऑरोरा बोरियोलिस. ऑरोरा ऑस्ट्रियालिस हैपन इन द साउथ पोल, ऑरोरा बोरियोलिस हैपन इन द नॉर्थ पोल. सो देयर इज अ बिग क्वेश्चन कि ये होती क्यों है, ऐसे कलरफुल चीज़ें क्यों आता है, कहाँ से आता है, तो वी आर गोइंग टू सी दैट एज वेल. सो व्हाई डू ऑरोरा ऑकर्स? देखो, we have seen that there is a earth magnetic field, and this earth magnetic field repel, not allowing the radiation of the suns to come inside the earth, and it protect our environment, it protect the life on the earth. But sometime what happen, I am just going to show you. Sometime what happen, you can see the diagram, you will understand there. Let me show you the diagram. You can see in the north pole, you can see in the south pole, there is a weak in magnetic field. Now, देखो, this shield is there, this shield is there. So here energy particle cannot come. But in north pole, south pole, there is no such shielding. Shielding is quite weak in the north pole and south pole. You can see here. In north pole, shielding is not there, and south pole, shielding is not there. So because of that, whenever this charged particles, sometimes they enter near north pole, sometimes they enter near the south pole. That is the reason only near north pole, only near the south pole we found Borealis australis and aurora borealis, aurora australis. ठीक है, चलो चलते हैं वहाँ. So from here lot of question also asked, so we are going to discuss that as well. चलो आगे बढ़ते हैं. ठीक है, aurora begins with the activity ठीक है. So aurora begins activity on the surface of suns. The suns constantly emit charged particles. Suns is always emit not only the light but also the charged particle constantly in all direction, and some of them are coming towards earth and they are interacting with earth magnetic field. They are quite strong in all directions, so they cannot come inside, but at the pole region they are is quite weak, so they try to enter that. Okay, so mainly this charged particle consists of electron, proton and magnetic field, collectively known as solar wind. So if there is a question, what is the constituent or what solar wind is consisting of, you can say electron, proton and magnetic fields. So the solar wind approach the earth, it encounter magnetosphere of earth, and this magnetosphere deflect most of the solar wind, acting like a protective shield. Some charged particle from the solar wind became trapped by the magnetic field and particle channel along the magnetic field lines north and south pole. Some of them might enter into the north pole and south pole. The charged particle in upper atmosphere, you can see the charged particle in upper atmosphere collide with gaseous molecules like oxygen and nitrogen. This collision transfer energy to the gas molecule, which then release energy as a light. देखो, in north pole and south pole, in north pole and south pole already we have seen that there are lot of protective layer other regions, so there is no coming of any charged particle in this region, but some of them are coming here and they are interacting with the gaseous molecule there like oxygen and nitrogen. Whenever these charged particles, they interact with this region, so they create a glow light, and this glow light is called as aurora borealis, aurora australis. I think आपने देखे होंगे इलेक्ट्रिक लाइन्स में भी होती है, बैड वेदर कंडीशन में there is a sparking glow happen. This is what called corona effects. ठीक है, so here also happens same thing. So because of this, this interaction, so they transfer energy to the gas and release this energy as a light, creating aurora. The type of gas and altitude of interaction determine color of aurora. You can see whenever this charged particle interact with oxygen, green most common, sometime red also. So nitrogen create blue and purple and violet shade. So we can say that different gas help in generating different colors. Under normal condition, aurora are mostly visible near pole. Under normal condition में आपको पोल के आसपास में देखने को मिलेगा, because pole is having strong magnetic fields. However, during intense solar activity means when sun is more powerful. When sun is more powerful, it's shedding lot of charged particles. When sun is shedding lot of charged particles, so they try to reduce the magnetosphere of earth, and in that case more particles can comes to the towards earth and there will be more activity of aurora. ठीक है, so aurora can be seen in lower latitude part of the Europe and US or even India's like Ladakh region. We can see whenever sun is emitting lot of charged particles towards earth, so at that time earth magnetic field became little bit of weak, and because our earth magnetic field is little bit of weak, so this charged particle try to emit and enter within the earth. So that is what happened. Okay, ठीक है, so this is all about the aurora borealis, aurora australis. So I think we'll have to end our class here. So I was started little bit of later because of some electricity problem. From tomorrow onward we'll start from 7:30. So next class will start from geomagnetic storms. So dear student, whatever I have discussed, so please study that, revise that, please do mapping work, and the question I have given, you have to write what is continental drift theory, write down the evidence in support of continental drift theory and discuss its limitations. ठीक है, so यही, this is a 15 marker question, you have to write and submit. So I'll do evaluation. So dear student, we'll have to end our class here because we'll have to take we'll have some other work as well. So this batch we are starting from 7:30 to 9:30. Class is happening and batch is live. You can join this foundation class. It is already available in application. You can contact if you want to join this foundation class. You can contact 72176 3385. So this is foundation class is going to cover your OPSC examination, UPSC examination, and here in this foundation class you will get not only the complete coverage of prelims, mains, you will also get the mentorship, you will get the test series, ठीक है. We are also going to cover your NCERT, CSAT, and those who are from the Odisha, they will get Odisha specific coverage and coverage of common paper like English and Odia. So, this is what you will get. This is a package, everything you will get under this program. Chaliye dear student, we will have to end here. Bye bye. Take care. Jai Hind.